up and try again.
Hi everybody, welcome back. We're going to continue this session of linked list. This is the third video that we're discussing about how to make the linked list. We start with the node data structure that we're going to store a value, and the next, basically this creates a box where we can provide a value and a connection to the next node through the element next. We demonstrate this in previous examples by creating a couple of nodes and then establishing the connections. And then we demonstrate also methods that will take a node as a parameter. And basically will print all the values that are in this connection. We use this using a loop, and we also provide a recursive implementation of this. Today we'll talk about the linked list. So basically the node and the node tester is only to demonstrate the actual box, the node. Notice that we can demonstrate that only by using fairly simple amount or number of nodes. But in real life, when you want to store a lot of information, say terabytes of information, the node, it doesn't make a lot of sense to just establish the connection one by one in hand. We need a mechanism that allows us to do that connection. That's why we introduce my linked list. I call it my linked list because Java provides a linked list in the library util. So just to avoid confusion, I put the my. If you see books, they also do that. Some books I have seen that they put linked list 1, linked list 0, linked list R, my linked list. That's only to identify the difference between the linked list that Java uses as part of the utility, the generics, and the one that you're going to implement. We're going to see a couple implementations of my linked list. But for now, I just want to let you know that for linked list, we need a first and we need a last. Now both of them, both first and last, are nodes. Let me just explain this real quick, why we need this particular first and last. We need to make connections between the actual nodes. So we introduce the first and the last as part of those elements. So first, we'll take care of the very first element in the list, and the very last one. So at the very beginning, first and last will be nodes that will be pointing out to something called the null. We discussed about the null in previous methods. Those three lines are the way we denote the null, N-U-L-L. So null is the default value for any object in Java, but at the very beginning of the node, we decide to create the next as a null because it's an object. So when we define these two methods, these two fields of my linked list, they're gonna be equals to null. And you know what? It doesn't hurt to create a constructor, a default constructor where first is the same as the last, which is the same as the null. It helps. So that's how we're gonna start implementing my linked list. Another method that doesn't hurt to have is maybe some relation or some checker, just called isEmpty. So isEmpty will check if the actual data structure, my linked list, is empty or not. Let me show you a diagram that I have here. So when you add an element, like are you seeing right now here, when you add something like that, that means that the first and the last will be pointing to something that you just create. But previously, when you just have an empty linked list, like what you're seeing here, that means that the list is empty. So first is responsible, also last, but first at this point, it will be responsible to check if the list is empty or not. And how do we check if the first is pointing to this null, then that's a signal that the linked list that we just have is empty. So we can write a method that is going to return a Boolean, and that's by checking if the first happens to be the null. That's enough evidence to figure out if it's empty or not. Okay, so it doesn't hurt to have it. It's going to be very helpful later on to check if a linked list is empty or not. Now, if we come back here, I already have these notes for you in the website. Yeah, the next element that probably would like to have is the add. And this is where the interesting thing takes place. Public, we're gonna set just void add. Suppose that we're gonna add strings into the linked list that we're creating. So the very first thing we have to create or check is we need to check if this list is empty or not. If it's empty, that's very easy. If it's empty, we're looking for this particular case that we're talking about, that the first and the last is equal to null. So when we provide a value, basically the first and the last will be the same value that we just stored. So we're gonna create a box like what you see here called the node, and we're gonna stick there the actual value that we're planning to store, and then we make the reference of the first and the last. I usually make the reference here when, for example, if it's early in the morning and then someone asks you how many coffees you have, coffees. So if you haven't drink any coffee at all, you have nothing, right? But if you just go and get a coffee, then you have a coffee cup in your hand. Someone is going to ask you which one is the first coffee that you have drunk. You're going to point to the coffee in your hand, and which one will be the last one? Well, it will be the same, because so far is the same value that you have. So this is what we're going to do right now. If it's empty, then we know that the first and the last are going to be the same node. Yeah, we're going to start with this. Remember that we create a class node, and we're going to use the very first constructor. If you don't remember, it's right here. We're invoking this method, the method that we have, not the method, sorry, the constructor that takes a string. That string will be the value, and the next will be the null. Yeah, we're invoking this constructor on line 13. How about if it's not empty? If it's not empty, then we need to do some kind of relation here. Usually when you add something to the list, you add it to the last. Yeah, you can imagine if you go to a supermarket and you put a cart, just put things on the cart, right? Or you're purchasing something online, you just when you add something, you just add it to the end of the list. It's exactly the same situation. We're gonna create a new node containing those values that was provided. And this is where the trick is, and it's not really a trick, but people get confused with this. When you add a new node, it's gonna be assigned to something. It's gonna be assigned to the last .next. Yeah, I'm gonna explain this in a little bit. And then after you perform that action, then last will be your last .next. These two lines of code, they're not difficult to understand. It's just challenging to see what we just did. Let me see. When it was empty, it's easy because the first and the last will be that. But suppose it is not empty, then you will have to create a new node. Yeah, with that value s that we provide. We use the first constructor, so this guy will be pointing to the null. S represents the value of the string. Now, notice that the first is pointing to this guy and last is pointing to that guy, to the same guy. So when we create a new node in this line of code, when we create a new node with that value s, last.next will be pointing to that value. So the last dot next is this bloop thing. It will now point to the S, to this new value that we have. Now, the next line is that we need to update our last, because the last that we have here is still pointing to this element that we're first is pointing. So last is going to be updated by who? By last.next. Now that's your new last. Yeah. It looks very weird with Microsoft Word here. I apologize for that, but that is actually what's happening. So I'll try to do another video for actually demonstrating this part, but in reality, it's pretty simple. When we create another element, or where you want to add an element, you add it to the last. And then the last, after you add it, after you establish the connection with this arrow, yeah, after you establish that, then you update your last. That's pretty much the whole trick. And that's here, yeah? So what we can do, let's make a tester so we can demonstrate this whole part. Let me just save this guy in the directory. Desktop. We have the main. We're gonna create a my linked list. We're gonna call it list. Let's name my linked list. Now, the very first thing we're gonna demonstrate, if it's empty, of course, is empty. So basically, we're gonna call the list dot is empty. So we're gonna demonstrate that. I'm expecting that is true. Oops, tester. Hold on. Java C my linked list tester, and then Java my linked list tester. So I'm expecting true. It is true, that is false. Now I'm gonna add one element, and actually I can demonstrate, I don't know, adding a let's see, adding C. So on list, we're gonna add the letter C, the string C, and then we can ask again if it's empty. Yeah, we're gonna ask if it's empty now. Now notice that on line 6, what I'm gonna do here basically is gonna call add on my linked list. It's gonna come here and add. Since it's empty equals to true, yeah, we demonstrate that here. We already have it's empty is equal to true. We're gonna come here and gonna say, hey, you know what? The first and the last, they're gonna point to the same guy, which will be a new node that I'm gonna create with that string S. In this case, it will be C. So basically, we're gonna do that, yeah? So it's empty now is going to be false. Yeah, so it's false. Now, if you want to demonstrate to see what is the first and what is the last, we can check. This is not okay, guys, because usually the field should be private and I should not be able to access them from outer class. For example, check for first. So we can do something like this, list.first.value. I'm expecting C here. And also we can do the same situations for last. Again, this should not be okay because I should not be having access to the fields from here. I can make accessors if you want. What? Okay, something went wrong. Reopen. Let's see what happened. Something crashed here. Oh man. Okay, let's see. Okay, so here, okay, first and last. Okay, nothing changed, hopefully. I'm just gonna change directory to desktop. Okay, if you notice, I should put here last. The first is that, the last one is that. So at the very beginning is empty, it is true. We add the string s. Now we check, hey, is empty, false. There's something there. How do we know? Well, the first is pointing to the string to the node containing the value c, and the last is pointing to the node containing the value c. So both of them, they're pointing to the same node, which is the node containing the value c. Okay, I have to say it that way because that is the way you should be read it. We're not pointing to c, we're pointing to a node, and inside of the node happens to have the value containing the string c. That's why I have to do all this thing. We can fix this by a toString, but I was going to explain that later on. But you can transform this into a string so it can give you a toString, give you that value. Now, let's add another one. Let's add s. And you know me, I'm very lazy, so I'm just going to copy this thing. If I can copy. And paste. Of course, we need to say now, after we add the s, we're adding the string s. Okay, this looks nicer if we put the quote here. Okay, so we're gonna do the same. We're gonna compile my linked list tester, and we're gonna run this thing. And then again, when we add the c, we check if it's empty. Now it's false. First and last, they point to the c. Now, in the next stage, we're gonna add the s. The first is pointing to the string c, and the last is pointing to the string s. You see how that actually changed? The reason is because we add into the end. If you remember, this method, the add is, in case it's not empty, the last is the responsible to accumulate the next elements that we're pointing to. Very important. So have that in mind when you create an add method. And the next thing that I was going to explain is the size, but those are kind of methods that are going to, okay, fine, I'm gonna give you the size. Yeah, if we want to find the size of the current size of the elements that we just add, the method public int size, it doesn't really take any argument. So what we're doing here is that we're going to count how many elements has been added so far. For that, we need a counter. You probably remember that from the very first course. And we need to return the counter immediately just to make sure this guy compiles. Now, and this is what I was telling you in the previous lessons, we need some kind of dummy variable, a temporary variable that help us to navigate through the entire list without sacrificing the actual reference of the values that we have first or last. So we can create a temporary variable or a dummy that will point to whoever the first is pointing to. And as long as that dummy variable doesn't really hit the null, we will continue doing a couple things. First of all, we're gonna increment our counter by 1, and then we need to move on from a temp to the next one, like this. Okay, line 21 is the variable that will keep track of how many elements we're gonna count in this list. Line 22 will basically store a reference to the very first value, the very first reference of this linked list. Now, line 23 to line 26 is the mechanism that we're gonna navigate through the entire list. As long as we don't hit the null, which is the last part that we want to achieve, yeah, we're gonna add one by one our counter. That means that there was something there. And we're gonna move forward, yeah, by using temp.next. Your next question probably is why temp? Is because we need a dummy or a variable that is a placeholder that basically will take the reference of first. We don't want to sacrifice first, because if we use first here instead of temp, when we're done with null, basically you're empty your entire list. That's how you make your list empty, to put everything to null. You need to be very careful on this procedure. This is very, very important. So I'm just gonna compile this thing. I'm gonna demonstrate here total elements, yeah, and then we're gonna increase, I'm gonna call the list that size, like that. I'm expecting 2 here. Let's add a couple more things. Let's add I don't know, some random things, and maybe that's enough. How many we have? 1, 2, 3, 4, 5. Okay, so we're gonna compile this guy again, and we're gonna run it, and I'm expecting 5. There we go. Okay, so I'm gonna, so that's that. Yeah, let me just move in order to avoid confusion, because I just want to make sure I didn't demonstrate that by seeing what happened. So I'm gonna demonstrate at the very end who's holding what. Yeah, and I'm just gonna, every time we add, I just want to make sure I report that I'm adding, for example, B. Here I'm adding, no, that's not what I wanted to do. I want to have adding. This is the problem with being lazy. Sometimes you're confused what to add or not. Adding, you add S, here we add B, here we add D, and here we add N. Now, this is only for reporting purposes. And since I'm gonna post this on the website, I want you guys to understand line by line what am I doing here. Okay, so we add a couple of things here. At the very end, the very first is pointing to the C, the very last is pointing to the N. Yeah, there's a total of 5 elements, and that's how we demonstrate those basic methods in the class myLinkList. I'm gonna continue with other methods in the next session. Please let me know if you have any questions.